Now, let's narrow down to just algorithms, okay? And sometimes it's actually very advantageous to use probability in algorithms, right? So here's a great example. This is a great algorithm. This is one of those algorithms that computer scientists, many of them, I'm sure, okay, probably have tattooed on their forehead. This is quicksort, and it's one of our favorite algorithms. So what does it do? You pass in a list, and it returns a sorted list, right? So if you pass, for example, 10, 7, 5, 2, then it will return 2, 5, 7, 10, right? The same list, but in ascending order. So here's the way that it works. The first thing that it does is it checks, this is the base case, right? Hey, am I looking at a list that's already sorted because it has no elements, in which case, of course, they're in order, or only one element, in which case, of course, it's in order. Then this is just return that list. It's already sorted, okay? So it's kind of the base case, okay? Otherwise, we're gonna look at what I call the small x's, right? And these are all the ones. This is a list that contains, okay, the elements less than the first element, right? So we're doing this check. X is less than, and this guy here, of course, is the first element. So we're saying if it's less than that, then we make it into that list. The big one contains all the ones that are greater than or equal to the first x. Okay, so x is greater than or equal to x sub 0. All right, so now what I do is this. I take the small x's and I sort them, right? So that gives me everything smaller than the first element, but in increasing sequence. They're all smaller than the first element, so the very next thing in the sorted list should be the first element. And then we take all the ones that are bigger than that first element, sort them, and put those at the end, all right? So I have the small ones, I have the first element, I have the big ones. And the small ones and the big ones are in order. The entire thing is in order because of the way that I split into small and big. Okay, so this is a great algorithm. It's a beautiful algorithm. It's probably the algorithm that you use in your computer when you sort something like in Excel and you say, yeah, sort by this column. I bet you it's using quicksort. Okay, there's one tiny problem with quicksort. Let's say that I ask it to sort the numbers from 1 to 1,000,000. Okay, then it's going to go along and say, oh, I want to find all the elements that are smaller than 1 because that's the first element. There aren't any. Okay, all the elements that are greater than or equal to 1, well, there's 999,999 of those, right? Because it's everything except the first element. Okay, so sort the small ones, there's nothing. Put in the 1, and then put in the sorted version of 2 through 1,000,000. Okay, how do we sort 2 through 1,000,000? We'll take the 2. All the small ones, there aren't any. All the big ones, there's 999,998 of those, right? Okay, and then we have to sort those, right? So you see what's happening, right? Instead of kind of splitting the small and big into roughly equal sizes, there's nothing in the small and everything is in the big. So how long does that algorithm take? Okay, you might here recognize an arithmetic series or Gauss's trick, right? Because what I'm adding is 1,000,000 plus 999,999 plus 999,998 plus, and so on, right? All the way down to 1, okay? That sum, that's 1,000,000 times 1,000,000 plus 1 divided by 2. Let's just say it's roughly speaking 1,000,000 squared, okay? 1,000,000 squared over 2 is more accurate. All right, so how big is that? 1,000,000, multiply that by 1,000, that gives me 1,000,000,000, multiply by 1,000 again, that gives me 1,000,000,000,000, right? Divide by 2, 500 billion. Okay, 500 billion steps. That's an awful lot of steps. Okay, now there's actually an easy solution. Okay, and the easy solution is to pick an element of x's at random. Okay, so instead of always picking the first element, I just pick one of the elements at random, right? And now there's a reasonable chance, okay, that half of the elements are smaller and half of the elements are larger. So I get essentially even small x's and big x's. Half might be hoping for too much, but even if it's just a third and 2/3, then this works out, okay? And think back to our discussion on trees. So the min order would give me like a third, and max order it gives me like 2/3, right? That's really what's happening here. Okay, so now how many steps is it going to be? Well, it's just a log, okay? And the log of 1,000,000 is, depends on what base, but roughly speaking, we're talking 10, okay? And so it's 10 million. 10 million as opposed to 500 billion. It makes a huge difference, right? So picking that element at random is actually a gigantic one.